Start.
Good evening, students. Today we are here to discuss electrostatic potential energy difference. That is nothing but work done in moving any charge from one point to another in an electrostatic field without acceleration is known as the potential energy difference between those 2 points. Let us focus on this diagram. Let us consider this is charge Q and this is charge Q naught at point A. We want to take this charge at this position B. Let this distance is R1, this distance is R2. While taking this charge from this point to point B, let us consider this charge comes at point P at a distance R from charge Q. Then the force acting on this charge is given by F is equal to K Q naught by R square. Then the small work done in moving this charge dW is equal to F dot dr vector. Now mind it, this force is electric force whose direction is towards right side. We are taking this charge towards left side. Then force and displacement have an angle 180 degrees between them. So while taking this expression, we will consider it. So it will be F dr cos 180, which will become minus F dr, as we know that cos 180 is equal to minus 1. So put the value of F over here. We get dW is equal to K Q naught by R square dr negative. Now this small work done will be integrated up to the limit from R1 to R2 to find the total work done. Then the total work done will be integration of this dW. It is equal to integration of minus K Q naught by R square dr from limit R1 to limit R2. So we know K Q naught are constants, so we can take them out, and remaining part is 1 by R square dr from limit R1 to R2. It can be further written as integration R power minus 2 dr from limit R1 to R2, which can be further calculated as R power minus 2 plus 1 by minus 2 plus 1 from limit R1 to R2. So by integrating we get W is equal to minus K Q naught by minus 1 by R. Lower limit is R1, upper limit is R2. So this minus and this minus make positive, and upper limit minus lower limit, we get integration like this. It can be taken out, this and this. This is the potential energy at point B, this is the potential energy at point A. So W is equal to potential energy difference while going from point A to B. So work done while going from point A to B is equal to the potential difference between those 2 points. Here, mind it, I have mentioned the word without acceleration, means we are taking this charge in this electric field without acceleration. How it become possible? Because at this point the force is electric, that is Fe, and we are applying some force, that is F, that should be numerically equal. F should be this Fe, so that net force on this charge becomes 0 and net acceleration on this charge also becomes 0. Then while dealing with the formula of force, we take this force, that is F electric. This F electric, that's why I have taken the formula K Q naught by R square. Now this formula is very important in many respects, because from this term electric potential energy difference, we get the term potential energy, we get the term potential, and we get the term potential difference as well. Now the basic difference between these definitions are, now we are taking this potential energy difference is equal to the work done in moving the charge from one point to another. So this is equal to the difference in their potential energies. If one point, that is point A, say it is at infinity, so R1 can be taken as infinity and R2 can be taken as R, then W is equal to UB minus U infinity. What is U infinity? When this distance will be infinity, this term would be 0. So that can be written as UB minus 0. That is equal to UB. So this work done is equal to the potential difference at point B. So I can say that potential energy of point B is nothing but work done in moving any charge from infinity to that point in the electric field. So electric potential energy at any point of a charge is defined as work done in moving that charge from infinity to that point. Now the next topic is electrostatic potential difference, that is very much similar to the previous topic, that was potential energy difference. That was the definition, work done in moving any charge. Now I am taking unit positive charge. That is the only difference between this definition and that definition. Work done in moving unit positive charge from one point to another in an electric field without acceleration is known as the potential difference. Potential difference between those 2 points. The diagram, the concept would be same. Now focus one thing. If we take the Q naught charge from one point to another in an electric field and work done is W, then work done in moving unit charge would be equal to W by Q naught, and by definition this is potential difference V, or say potential difference VB minus VA is equal to W by Q naught. This is known as potential difference. So if I take potential difference, as we know, W was KQ Q naught by R2 minus KQ Q naught by R1. So what is VB minus VA? That is equal to UB minus UA by Q naught. That is equal to Q naught by 1 by R2 minus 1 by R1 divided by Q naught. So we are left with what? KQ by R2 minus KQ by R1. This is net potential difference between those 2 points, VB minus VA. So, as in earlier case, we were taking two definitions, potential energy difference and potential energy. The basic difference was, in potential energy difference, we were taking the charge from one point to another in an electric field, and while dealing with just potential energy at any point, we were dealing that charge was coming from infinity. Now the difference is we are taking unit positive charge. So in potential difference we were taking unit charge from one point to another in the electric field. Now if we are dealing with electrostatic potential only, not difference, remove it, electrostatic potential, it will be at some point in electric field. So if R1 is equal to infinity, then VA will be equal to KQ by R1 is equal to KQ by infinity is equal to 0. Potential at infinity would be 0. So all the difference will be equal to the potential difference. VB minus VA will be equal to VB. That is potential at point B. That is equal to KQ by R if R2 is equal to R. Then, so we require only one point. Its position vector, its charge. That's it. So potential at any point is defined as work done in unit positive charge from infinity to any point in electric field. So its unit is V is equal to W by Q again. Its unit is volt. So volt is equal to joule by coulomb. So 1 joule is equal to 1 volt is equal to 1 joule by 1 coulomb. That means when the potential at any point is said to be 1 volt. If we are moving unit charge from infinity to any point in electric field and we have to do work of 1 joule, then potential at this point would be 1 volt. That's it.